Hello guys, this is your host Lucas and you are watching a new episode of the Numberverse. Today we're gonna solve this integral, this antiderivative dx over 1 plus root x all to the power 4. Can you figure it out? Let me know your answer in the comments section. Give this question a try, and when you're ready just keep watching the video for the solution. Let's do this, but first, if you haven't subscribed us yet, press the subscribe button for more such content. So if you're not careful, this could scare you. It doesn't quite look like many of the things you're used to, and you might be tempted to use AU substitution, and you could find very quickly that it doesn't match the normal flow for AU substitution. There's nothing to cancel out once you take the du, but maybe we should go with our gut. Let's in fact go with our instinct. And let's u be the thing you would guess it to be, the thing inside the parentheses, right? U is usually the thing inside the parenthesis or under the square root or in the exponent of e, that sort of thing. This would make du the derivative. Well, the derivative of 1 is 0, and the derivative of root x, you could think of this as x to the 1½ power, and use the chain rule, but I prefer to remember the derivative of a square root is 1 over 2 times the square root, and I need to tack on dx when I'm doing this differential. You'd get this same result if you use the power rule and then rewrote the answer using radical notation. Some people prefer to solve for dx here. If you want to rewrite this equation solving for dx, multiplying both sides by 2 root x, we'd have 2 root x du, this is equal to dx, and what we can do is we can make our substitution. Now I know what the dx is. In the numerator I know dx to be 2 root x du, so I have my du in there. I need that du differential. If I'm going to do this substitution and in the denominator 1 plus root x we called that u, it's still to the power 4, well this would be great, except we have x still. I can't integrate x if this says du. How do I figure out what root x is? I have this dangling root x out here. Well, hold on, there's a root x right here. I know what root x is. I'll just solve for it. Just subtract 1 from both sides. U minus 1 is root x. Some people call this a back substitution because I look back, and now I'm gonna substitute, so I'm gonna resubstitute this. It's 2, and if you like you could even just throw this 2 outside of the integral, right? I can pull constants out front. Root x, I know what this is. Now this is u minus 1 times du over u to the power 4, and this is something much more manageable. We can definitely integrate this. In fact, I think the best way to do it would be to split up this fraction. I would just rewrite this as 2u over u to the power 4, and then minus 1 over u to the power 4. This is still times du, and if you like you could rewrite this without any fractions, just using properties of exponents. Here u over u to the power 4, that would be 1 over u cubed. Equivalently you could write that as u to the power minus 3, and 1 over u to the power 4, that's u to the power minus 4. And now we're all ready to do our antiderivative. Add 1 to the power divided by the new power, so I'll do just that. Minus 3 plus 1, that's minus 2. I divide by the new power minus 4 plus 1, that's minus 3, divided by minus 3. Every good indefinite integral deserves a plus c at the end. Now I started with x, I'd like to end with x, so everywhere I see u I'll replace it with what I know, u to be 1 plus root x. Okay, so I could rewrite this a number of different ways. Maybe I'll just leave the 2 out front. I'd probably just leave this as a negative 1 over 2, just rewriting the over minus 2 as minus half. And I'd rewrite this with a positive exponent in the denominator. Squared u was 1 plus square root x, and then same deal here. I'd have minus 1 by 3. I'll bring this downstairs to make it a positive exponent again. U was 1 plus square root x. And then there we go, and there is a nice antiderivative. You could check if you really wanted to. I hope you enjoyed this video, kind of a wacky integral. Thanks for watching. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more such content. If you have any interesting brain teasers or puzzles, you can share with us by fill out a Google form. Link is mentioned in the description.